Hello everyone and welcome. This is Clover. I'm going to go over a guide to gear ratios. So, analyzing gear ratios, calculating gear ratios, relationships between engine speeds and road speeds. So you can't really find any wisdom on the internet. So I'm just going to go ahead and share some of my thoughts. I've really thought about this for a large portion of my life, so here it goes. So I've made this little graphical tool on Desmos. I don't take credit for Desmos, but I do take credit for this tool. Here's the link. Don't worry about any of these equations or formulas. You just have to really worry about the variables. So this is the maximum engine speed, or whatever engine speed you want really, but it's just set to maximum. So variable m. This is revolutions times 1000. So right now it's set to 6800 RPM. And then these R values are your gear ratios. And then you come down to T, that's your tire size and diameter, that's in inches. F is your final drive ratio. And you can do a 6-speed, or you can do up to 10 speeds using this. Come down here, T2, F2, those are your alternate. So you can compare between a 6-speed and a 10-speed, or you could just do one or the other. If you want to change between them, you just deselect these lines and then reselect these, so that's how you would visualize that. The 10-speed is preset to the Honda 10-speed. This is the Honda Odyssey specs right here. And the 6-speed is set to the Honda Fit 6-speed. So how would you calculate the relationship between engine speed and road speed? So it's pretty easy. So you just have to we're going to take the specs from a Honda Fit. So you just have to first find the tire size, the diameter in inches, and you can calculate that really easily. So you take this number right here, that is your width. So you multiply your width in millimeters times your aspect ratio. So it's just 60%, so times 60 divided by 100, or just times 0.6. So that's the radius of the actual sidewall. Then you double it, and then you multiply it. Actually divide it by 25.4, and then you add the actual size of the rim. That's going to give you your tire size in inches, the diameter in inches, and you want to save that value. Multiply it by pi, divide by 1.056, divide by your final drive or your axle ratio, and then divide by whatever gear ratio. So we're going to use 6th gear ratio. That's on the Fit. So there's the final drive. Sometimes it's called the axle ratio. And here's 6th gear. So this is 1000 RPM right here. It's 1000 RPM. So if you want to find a different RPM, you just have to change the divide by 1000, and then you multiply by whatever speed you want, or whatever engine speed you want. So 2700 RPM, you'd be going 56.7 miles per hour, and we can verify that. 2700 RPM and 56.7 miles per hour. So that's just to show that it's accurate. Let's get away from that. And so you just divide by whatever value you're currently working with. So like we're at 2700 RPM, we want to change that. Divide by 2700. And let's say you want to see what it is at 2000. Let's divide by 2000, so 42 miles per hour. And to convert it to kilometers per hour, you just multiply by 1.609. So at 2000 RPM, you'd be at 67.6 kilometers per hour. And if you want to change the gear ratio, let's go back to 1000. So divided by 1.609 divided by 2. So this is 1000 RPM and 6. Let's say you wanted to see what it was at first. So you just divide by 0.727. No, multiply by 0.727. And then divide by your first gear, so 1000 RPM, 4.4 miles per hour first. Anyways, so that's fundamentally how you would calculate that. So this tool gives you a graphical representation of your gear ratio spacing. So the vertical distance is your RPM gaps, the spacing between RPM between gears, and the horizontal gaps at the top here represent gaps in speed. And I'm going to use terminology short and tall. So when I'm talking about short gears, I mean this distance right here be very small. So first gear is considered a short gear because this distance from 0 to, what is this, 30 miles per hour is very short. It's a very short distance. And a tall gear would be like 6. 6 is normally a tall gear. So this distance is much greater because it's a taller gear. So if I change the final drive, I can make the gears taller, very tall gears. So let's see. Now to find out what speed it's going to go at a certain RPM, we can just click the red line, and at 6800 RPM and 6th with this final drive 3.3, which is not what it actually is, but it'd be going 200 miles an hour at 6th if it could, if it had enough power, which it doesn't. That's just theoretical. Let's change that back. 4.625. Well, let's say you wanted to see what it was at 2500 RPM, just 2.5. Click the red line, 6th gear, you're gonna go 52.5 miles per hour. And in first gear, you'd be going 11 miles an hour. Alright. So this only works for miles per hour and RPM times 1000, but if you're trying to convert to kilometers an hour, just multiply miles per hour times 1.609. Yeah, this is a graphical representation. So I'm going to go ahead and talk about gear ratio theory a little bit. So you can see there's a trend here. These gaps, as they go on, as you get higher gears, they get closer together. Like the ratios get closer together, so the RPM gaps get smaller and smaller. And then the speed gaps, normally they tend to grow gradually, but here is a little bit of a different scenario because the Honda Fit is a little bit exceptional in that these gaps actually get smaller as you go on. That's definitely the exception, not the rule. So this is just what the Honda Fit looks like. If we change this to the Honda Accord V6, you can see here are the gear ratios, and we can calculate this again. 235 times 0.45 times 2 divided by 25.4 plus 18, and 26.33, 26.33, and we can go ahead and change these. So this is what I believe is a good example for what gear ratios should look like. When I'm done here, you'll be able to see that as you get into the higher gears, the gaps get gradually closer together. They don't really stay level. They don't actually get bigger as you go on, and they don't get too close too quickly, which is kind of the problem the Fit had. And these gaps, the speed gaps, get gradually larger and larger. This is what you want to see. You don't want to have really anything else. There's a different strategy that's also acceptable. So you can have a portion of your ratios that are just for speed and acceleration, and then you can have a gear ratio, 1 or 2 gear ratios that are just for fuel economy, and sometimes they'll be a little bit wider, a wider space. So let's say we wanted that to be 1.05. So this is kind of what I mean. If you just wanted to have ratios that were for speed and acceleration, let's say maybe your top speed was 110. Obviously it's not going to be 110. Let's change that to final drive on Accord. Let's say your top speed is 143. Okay, maybe the Honda Accord V6 can go 143. So you just make 1st through 5th for speed and acceleration. Your 5th gear is going to top out at your max RPM and your max speed are going to coincide. And then you have 6th gear just for fuel economy. You're going to have a bigger gap, bigger spacing. And that's perfectly fine, because after this gap, after you hit this critical line right here, all these gears are only as good as they keep the engine speed low, right? Because if that was really close, like this wouldn't keep your engine speed very low, so it's not really helping you for fuel economy. I hope that made sense, but this is how things normally tend to go. This is what a good set of gear ratios would look like. Or you don't really want to have gear ratios skewed. Like, you don't want to have the gaps too close early on and too wide later on. You don't really want to have it all mismatched and wonky. I can show you an example of that really quick. So like the the Toyota Camry. Like take a 2011 Toyota Camry with a 6-speed automatic. Let me show you the gear ratios for that really quick. This isn't exactly what it is, but just so you can visualize it. So you got pretty normal 1st to 2nd gear, it's pretty wide gap. But then 2nd to 3rd is very close. You can see how it's a close gap. And then the gap actually gets bigger from 3rd to 4th. You can see it's a bigger RPM gap. And then you have about the same from 4th to 5th. It's a very wide gap. And then from 5th to 6th, it's very close again. So you got wide, close, medium, maybe kind of wide for 4th to 5th. So you can see this gap right here is pretty huge. So I would consider this wide spacing, even though this is about the same. And then you have a very close gap right here. These Camrys tend to be geared to top out in 4th, and then your 5th and 6th are just for fuel economy, which is fine because the Camry is just a commuter car. So I don't have a huge problem, but like imagine that this was 0.77, and that this instead of 1.9 was like 2.1. You can see that it has a gradual reduction in RPM gaps, and then a gradual increase in speed gaps as you go on. This would be considered better, but that's just not how it is. This is how Toyota engineers decided to skew their gear ratios. Like second and third are very concentrated, fifth and sixth are very concentrated. Not ideal. I mean, it works, it's fine, but like it's not ideal. And I'll show you the Jeep Wrangler JK. I'm not going to change the tire size or the final drive. This is just to show you the shape. So the new Jeep Wranglers anyways, the JLs, I think it is, yeah, the JLs. This is not to scale at all. As far as like speed, but like the shape is to scale. I can change this. 31.47 of the tires, and I'm gonna have to zoom out now. But yeah, this is what I consider skewed. So you can see you have these gigantic gaps early on, and then you have very close gaps towards the end. Now, this overdrive is kind of worthless, so if they wanted to make this better, they could just get rid of that overdrive, make 6th gear 0.81, 5th gear 1. I haven't changed any of the gear ratios yet. I've just eliminated 6th gear and brought these down. Now we can play with these. Make that 1.35, make that 1.91. And then 2.92. Now you can see it has a gradual reduction in these gaps, and that this is very gradually increasing. The speed gaps are gradually increasing, the RPM gaps are gradually decreasing. This would be considered better. So I hope that made sense. I hope that was helpful. If you want to use this tool, here's the link again. It's very easy to use. If you want to use the 10 speed, you can check all of those and then activate these. So this is the Honda Odyssey. It's 10 speed. You can see it's a very good representation of how the gear ratios are spaced. So you can see this gap right here is kind of close, and then it gets a little bit wider, and then closer towards the end. So this is pretty good for a 10 speed. I mean, there's not really that many 10 speeds, but this is kind of how it goes. A little bit wider RPM gaps at the beginning, and then closer RPM gaps towards the end. That's about how it goes. So I showed you how to calculate RPMs at a given speed, or a speed at a given RPM, given gear ratios. If you don't know your gear ratios, you can usually just Google them. So we can do that right now, actually. Duck.com. So like, let's say you had a 2017 Toyota Tundra. Just as an example. So you can look, cars.com usually has accurate specs. 6-speed automatic. Come down here, and bam, there's your gear ratios. but it's just, let's say you had a 1996 Acura Integra. Let's see. This website right here tends to have accurate gear ratios. Sometimes Wikipedia will have them, sometimes cars.com, sometimes, what's it called? Car and Driver sometimes has them. The Car Connection also tends to have accurate gear ratios. You know, if you look around, you can find what you're looking for. Worst comes to worst, somebody in the forums will know, or if you absolutely do not know, you can email the manufacturer directly. They can provide you specifications. Volkswagens are kind of vulnerable to errors because Volkswagens and Audis, some of their transmissions have like different final drives, so you kind of have to be careful. So don't always trust Audi and Volkswagens. Other than that, yep, there you go. So again, you just want to change, like if you want to see what it makes at 1500 RPM, you just 1.5, the red line, and then, so with this, it'd be 50 miles an hour at 1500 RPM. Yeah. I hope that was helpful. I'm gonna make some compilations of, I'm gonna basically critique some common gear ratio setups from different manufacturers. And yeah, hope this was helpful. Thanks for watching.